After a modeled structure is defined with applied loads, you can run several different analysis types on the structure. In this example, a linear static analysis will be run. With the model open, from the text menu, select Analysis Calculations. The Calculations dialog displays and immediately begins loading the analysis. After a brief moment, if no warnings or errors occur, the dialog closes. Be aware that the analysis is still possible if warnings occur, but it is not possible if errors occur. Once the analysis is complete, a notice that results FEM available appear both at the top and bottom of the program. Each load case combination will now have computed stresses and strains based on generalized section forces. To inspect the results, from the toolbar, expand the Cases dropdown and select either a simple load case or a combination load. In this case, the simple wind case is selected. Once a load is selected, from the text menu, select Results, Diagrams for Bars. The Diagrams dialog displays. From the NTM tab, to display sectional forces, select MY moment, and then click Normalize. Then, next to the diagram size, click either plus or minus to scale the diagram. The value updates in the My Moment field. You can also scale this value directly. Once configured, click Apply, and the drawing area updates to display the bending moment for all beams. Next, in the Diagrams dialog, use the arrows to navigate to the Parameters tab. Under Positive and Negative Values, select Differentiated. Then, under Filling, select Filled. Select Apply, and the drawing area updates again. In the diagram description, select Labels, and then expand the Values dropdown. Select All, and then select Apply. The drawing area updates to display textual information. Expand the Values dropdown once more, and select Local Extremes, and then click Apply. The values in the drawing area update. Expand the Values dropdown a final time. Select Global Extremes, and then click Apply. The values in the drawing area update to display the global extreme values. To display deformations, use the arrow in the Diagrams dialog to navigate back to the NTM tab and toggle MY moment off. Now open the Deformation tab and select Deformation. Click Apply. Structures that deform under the loads display. To animate the displacement, in the Animation section, select Start. A toolbar displays with the options to stop, pause, replay, and save the animation. In the drawing area, the displacement for simple load cases animates. Close the Animation toolbar, and in the Diagrams dialog, deselect Deformation. Next, navigate to the Stresses tab. In the Normal Stresses group box, select Maximum -S Max. Click Apply. The diagram of maximum normal stresses displays. Deselect Maximum and select Minimum instead. Again, click Apply. The diagram of minimum normal stresses displays. Deselect Minimum and then navigate to the Reactions tab. In the Reactions tab, you can select to display values of reaction forces at supports and reaction moments. Select Fx, Fy, and Fz, and then select Descriptions. Select Apply, and the drawing area updates to display the various reaction values. Deselect Descriptions. Select None, and select Apply. The values are removed from the drawing area. You can also present several components at once. Navigate back to the Parameters tab. In the Positive and Negative Values group box, select Undifferentiated. And then, in the Filling group box, select Fence. Navigate back to the NTM tab, and select MX Moment, MY Moment, and MZ Moment. Select Normalize, and then click Apply. To scale the diagram for each NTM state, select the value field of the state you wish to scale, and enter a value. Select Apply. To view the values in a separate window, click Open in a window, and then click Apply. The results open in a new window. You can click and drag the edge of the window to resize it to your preferences. To view results of another load case, you can expand the cases dropdown from the toolbar at any time. Select another load case. The drawing area updates to display the results of the selected load case. In the Diagrams dialog, select Normalize to normalize the results. To view a specific component of a selected limit state, from the toolbar, select Select Component. The Case Component dialog displays. From here, you can opt to use the slider to select a component or simply enter the component directly into the current component field. Once you do, click Apply to view the results. Click Close. To close the results window, click Exit. Before you finish reviewing the results, deselect all of the options within the Diagrams dialog. After everything is deselected, click Close. To view results of only a specific group of selected objects, from the text menu, select View Display. From the Display dialog, check Display Attributes Only for selected objects, and then click Apply. Now, in the drawing area, right-click a rafter, and from the menu, click Select Similar. Select by cross-section. Next, from the text menu, select Results, Diagrams for Bars. Again, from the Diagrams dialog, in the NTM tab, select NY Moment, and click Apply. The drawing area updates to display results for only the selected rafters. Again, you can change the load case at any time. From the toolbar, expand the Cases dropdown, and select a different load. Results display for the rafters specific to the selected load case. In the Diagrams dialog, deselect the MY Moment and click Apply. Then, in the Display dialog, deselect the Display Attributes Only for Selected Objects option and click Apply. Close both Display and Diagrams dialogs. For more thorough analysis of selection forces or stresses along a bar, select the bar in the drawing area. From the text menu, select Results, Detailed Analysis. The Detailed Analysis dialog displays. Click and drag along the top of the window to resize the results window. In the Detailed Analysis dialog, in the NTM tab, select All Moments and then click Apply. In the drawing area, the results display for the selected bar. From the Detailed Analysis dialog, navigate to the Parameters tab. From here, you can configure the display. Expand the Values dropdown and select Local Extremes. Click Apply. The drawing area updates. In the Data table, select the In Point field and move your cursor in the drawing area. A slider appears to indicate the exact position of the cross-section. This value displays in the Data table under Current Value. Again, you can change load cases while viewing results. From the toolbar, expand the Cases dropdown and select a different load case. You can also change the component by clicking Select Component, and then from the Case Component dialog, using the slider to update the component selection. The drawing area updates accordingly. Click Exit to close the results, and then close the Detailed Analysis dialog. To inspect object properties, including calculation results, right-click an object and select Object Properties. The Bar Properties dialog displays. Several tabs are available that include Basic Data, Calculation Results, and Code Calculations for a single structure bar. Navigate to the NTM tab, and from the Diagram selection, select FX. And from the Data table, select In Point. Again, the cursor acts as a slider in the NTM graphical viewer, so you can define the coordinate for relevant values. In the diagram group, select MX. The window updates to display the selected values. Again, click In Point from the Data table, and move your cursor over the window to view coordinate values. Next, navigate to the Displacements tab. In the diagram group, select UX. Again, select In Point from the Data table, and then move your cursor around the graphical viewer. Notice that the Data table updates to display values according to the current cursor position. Close the Bar Properties dialog. To review precise numerical values of forces in structural components, reactions, displacements, or stress, from the text menu, select View Tables. The Tables Data and Results dialog displays. From here, check each appropriate box for the data you wish to display. Select Forces, and then click OK. A table opens. Here you can view values, envelope, global extremes, or info. Close the table. To view the reaction's results as a table, select View Tables, and then from the Tables dialog, select Reactions, and again click OK. Again, you can view an envelope span of all cases solved, or results for independent nodes. Robot Structural Analysis provides a highly customizable process for manually creating and inspecting the results of a linear static analysis.